This wood is on fire, and it is putting itself out. 350 meters tall.
70 floors, built almost entirely from wood in Tokyo. Every building here is concrete and steel.
And stronger than concrete and lighter than steel. Engineered timber, stronger in tension than steel.
14 consecutive magnitude 7 simulations.
The wooden building walked away undamaged every time. Not just a building, Japan calls it a vertical forest. Japan's plan, 350, 4 times higher. Wood burns, wood bends, wood rots.
Japan has solved every single one. Cross-laminated timber. Boards at right angles, glued, pressed.
Stronger than the sum of its parts. Each layer fights the weakness of the last. No single direction of failure.
CLT chars at 1 millimeter per minute. The char seals the surface. 3 hours of fire, panel intact.
Japan developed MoenWood, fire-resistant timber rated to 3 hours, built for one building that doesn't exist yet.
MoenWood. CLT panels bonded with fire-resistant adhesive. Steel clad on the outer face. Concrete shatters, wood flexes. In an earthquake, flexibility saves lives.
This panel is bending under 40 tons. Steel cracked at 35. The wood keeps absorbing. That is the structural argument.
Glulam, 20-meter beams. No knots, no weak points. Stronger than the tree it came from.
Stronger than steel per kilogram. 1/5 the weight of the equivalent steel beam.
100,000 tons of CO2 locked inside the building. The W350 stores more carbon than it emits. 185,000 cubic meters of timber, equivalent to 8,000 Japanese houses, from one managed forest.
Every floor panel prefabricated off-site, installed in one crane lift. Wood is faster than steel here.
The outer wooden lattice is the structure. Every diagonal brace resists wind and earthquake.
The foundation is concrete, the only concrete in the building. Everything above, timber.
Seismic isolators at the base. The building moves, the foundation stays still. Fluid dampers in the bracing. Steel connectors at every joint. 200,000 individual connectors, each one transferring load through steel.
Every diagonal and joint in this model is tested individually. The W350 exists in this lab first.
800 millimeter square Glulam columns, CNC machined to 0.1 millimeter tolerance, carrying 30 floors.
Complete floor cassettes. Structure, services, finishes. Installed on-site in 4 hours.
Look at the turbulence around joint 3.
Yes, the drag coefficient is higher than predicted.
Tokyo typhoons reach 60 meters per second. The W350 is designed for 70. The 10-meter margin saves it.
The core is timber too. CLT walls forming lift shafts and stairs. Steel only at the connections.
CLT floors absorb sound better than concrete. Residents above will not hear residents below.
Wood insulates, concrete conducts. The W350 wall uses less energy to heat and cool.
Wood moves with humidity. Every connection designed for that movement, or the building tears itself apart.
Full-scale column tested at 140% of design earthquake load before failure. The real column sees 100%.
Insulated steel brackets at every connection. Structural capacity maintained for 90 minutes of fire.
Every timber component CNC machined. Connections accurate to 0.1 millimeters. Assembled like a watch.
That machine just cut a connection carrying 500 tons at 200 meters above Tokyo, in wood.
Central Tokyo, 37 million people around it. Every delivery, every crane lift, scheduled to the minute.
Tokyo's ground is soft alluvial soil, amplifying every earthquake. Piles must reach 50 meters down.
200 concrete piles. The only concrete in the entire W350 underground. The transfer slab, the last concrete pour.
Isolators positioned on the transfer slab. 400 millimeter horizontal movement capacity. The building will survive.
The first timber column bolted down. The wooden building begins above the concrete foundation.
Ground floor assembled in 2 weeks. Concrete takes 2 months. The prefabrication advantage is real.
1 crane lift, 1 complete floor section. Workers bolted in 4 hours. Done. The lift shaft forms from CLT wall panels. No concrete, no formwork, no curing time.
Steel braces in a wooden frame. 10 floors in 10 weeks. Concrete at this scale, 6 months minimum.
10 floors in 10 weeks. I am standing on timber 40 meters above Tokyo. The wood was a Japanese forest 18 months ago.
Services pre-routed inside every cassette. No chasing walls, no conflicts. The factory solved it.
The facade installs behind the rising structure. Workers clip panels into brackets. The building face emerges. UV-resistant oil treatment. The wood maintains its character for 30 years before first maintenance.
350 planted terraces, 1 every other floor. Workers installing irrigation that keeps a vertical forest alive.
Trees planted at 150 meters. Workers in hard hats handling root balls 40 floors up.
8 construction hoists, each carries 3 tons. 500 workers supplied to 40 active floors simultaneously.
Floor 20, 80 meters. Already taller than every building in the neighborhood. 1/3 of the way up.
Night shifts install floor cassettes while the day shift rests. The building grows by night too.
150 meters up, plumbed to within 15 millimeters. Every prefabricated component accumulating to near perfect alignment.
Active sprinklers back up passive wood fire resistance. 2 layers of protection, neither alone is enough.
No false ceilings, no cladding hiding the structure. Residents live inside the wood.
Exposed CLT ceilings, visible timber columns. The interior, unlike any high-rise ever built.
Perforated timber panels absorb sound. Better acoustic performance than concrete, visible in the design.
Elevator rails inside a wooden shaft. 1 millimeter alignment over 350 meters. Same tolerance as steel.
Floor 50, 200 meters. Mount Fuji, visible from the working floor on a clear day.
Upper floor winds halt cranes above 40 kilometers per hour. Tokyo's urban wind, unpredictable at 200 meters.
Every panel moisture checked before installation. Wet timber in a structure means movement. Movement means failure.
Spire section begins at floor 60. Columns slim, braces tighten. The building reaching its final form.
Final roof panel installed. Workers at 350 meters. The world's tallest wooden structure standing.
The facade complete. The render made real floor by floor. Wood and living plants against steel and glass.
The trees planted at floor 20 are now 3 meters tall. The building is genuinely alive.
No concrete, no steel visible. Entirely timber. Occupants report lower stress in wood buildings.
Hotel guests sleeping inside a forest, 200 meters above Tokyo. The most unusual hotel ever built.
Timber offices. Cortisol 15% lower than concrete workplaces. Japan building a healthier building too. "60-minute fire. Sprinklers at 2 minutes. Timber walls charred, structurally perfect. It survives its worst scenario." Timber walls charred, structurally perfect. It survives its worst scenario.
Borate treatment on every component. Harmless to humans, fatal to every insect that eats wood.
Interior humidity controlled to 40 to 60%. The timber stays stable. The connections stay tight for 100 years.
These gaps are not mistakes, they are the design. Without them, the panels fight each other and the building cracks.
1,000 sensors in the timber structure, monitoring every hour for 100 years of the building's life.
The damping system engaged perfectly. Look at the stabilization on the lower floors.
Yes, the data aligns with the simulation. We have a stable structure.
Design typhoon simulation. Peak sway, 600 millimeters at the top. Uncomfortable, but structurally safe.
Dampers cut peak acceleration to 15 milligrams, below human perception. Occupants at floor 70 feel nothing.
This damper absorbs a 70-story wooden building swaying in a typhoon. Japan spent 4 years perfecting it.
The timber harvested, replanted. The forest grows back within the building's lifetime.
Concrete equivalent, 50,000 tons CO2 emitted. Timber version, 100,000 tons stored, 150,000 ton difference.
Timber construction is almost silent. Central Tokyo neighbors barely disturbed. Concrete cannot match this.
90% less waste than concrete construction. Factory precision, almost nothing on the floor.
Every detail on this render has been tested somewhere in Japan. It exists as 7 years of tested engineering.
Every wooden building ever built shown beside the W350. The jump in scale is a complete category change.
New timber species tested for CLT. Faster growing plantation wood could have the forest supply requirement.
A complete digital twin. Every sensor feeds it. Every deviation from the model flagged immediately.
Robotic timber assembly tested at Tsukuba. 0.5 millimeter accuracy, faster than human hands, ready for 2035.
The ground floor open to all of Tokyo. A public park climbing 350 meters into the city sky.
Tokyo's temperature risen 3 degrees in a century. The W350 projected to cool its surrounding blocks by 2 degrees.
Rainwater harvested from the roof, pumped back to every terrace. The building waters itself from the Tokyo sky.
Solar panels built into the timber facade. The building generates power from the surface that defines it.
Japan's domestic forestry is declining. The W350's timber demand, a decade of revival for a disappearing industry.
Building the tower means building the industry. Japan is educating a new generation of timber engineers. 2018 concept.
Japan's W350 triggered a global movement. Wooden super talls plus London's Oakwood Tower, 300 meters, inspired by Japan. The race to build first has already started. This is Japan's vision. 2041. The world's tallest building, built.
This place is breathtaking.
Absolutely stunning. I can't believe this exists.
Living inside the W350. Timber above, timber beside, Tokyo below. No other high-rise offers this.
By 2041, this is either proof the engineers were right or the world's most expensive lesson in wood's limits.
If the W350 succeeds, the next 100 skyscrapers could be timber. One building changing how cities are built.
3 problems unsolved. Fire codes, insurance, cost parity. All being worked on, none solved yet.
Double the cost of concrete today. Japan needs to have it by 2035. As hard as the engineering challenge.
The path to cost parity. Robotics in fabrication. Large-scale CLT production. Standardized connection systems.
Bullet train, world's longest bridge, deepest railway tunnel, fastest train. Now, the tallest wooden building.
Tokyo 2041. If Japan builds what it has planned, this city gains a forest at 350 meters.
Japan built the bullet train when nobody believed it. They built the maglev. I have stopped betting against Japan.
If Japan's most impossible building moved you, subscribe. We document every floor. NEXTGEN Manufacturing.